So, Sebastian, put that away. All right. So we have here solving quadratic equations by completing the square. So we've done solving quadratic equations two ways already. Solving means find the x-intercepts, right? Solve for the variable, find what the variable equals. So we've done it by graphing calculator. We've done it by factoring. Today we're going to do by completing the square. And on Monday when you come back, we're going to do quadratic formula. The last lesson. So determine the vertex of each of the following quadratics and find the x-intercepts. So, and it'll say by completing the square. Or it'll say determine the exact roots. Exact roots means not decimal. So either it's going to be a whole number like 2, 4, 7, whatever, or it's going to be something square root something, like something plus or minus the square root of something, and you'll reduce the radical. You do not turn it into a decimal unless it's a numeric response box or something like that, and it asks you to. The very first thing when you're solving quadratics, or if we're trying to get it into completed the square form, we have to get everything to one side, okay? So we're going to go x squared minus 4x minus 11 equals 0. Then just like we did with completing the square before, we take out the front number. So we go square bracket. We take out the leading coefficient, 1. We take it out of the first two terms, x squared minus 4x. Because if I take out a 1, it doesn't do anything, right? Plus blank, minus blank, minus 11. The difference being here we have an equal 0 because you have to have it equal to 0 in order to solve. If I want the vertex, if I ever ask you if I give it to you in standard form and I want it in general form or vertex form, you have to complete the square to get it into vertex form to give me the vertex, right? So whenever it asks you to find the vertex and I give it to you in standard form, you have to complete the square. What's up, Shibo? Okay. So now we're going to go blank equals negative 4 divided by 2 squared, which is negative 2 squared, which is positive 4. Okay? Then we go 1 x minus 2, because it's what times what gives me 4, and what plus what adds to negative 4, x minus 2, x minus 2. And so we square it, because we technically have 2 of them, right? And we have to remember to multiply this number by this one. When it's a 1, if you forget it, it's not the end of the world, but if it's anything other than 1, like negative 1 or 2 or something, you're going to get it wrong. You'll have the vertical translation wrong every time. So 1 times negative 4 is negative 4, minus 11 equals 0. And so we get x minus 2 squared minus 13 equals 0. And so this is that vertex form, right? So we can pull the vertex right from here. The vertex is my P and my Q, so it's positive 2, negative 13. And that's from that previous lesson we did on completing the square, right? But now it actually wants me to solve, determine the exact roots, find the x-intercepts. So in order to solve, that means ultimately you want x equals something, correct? That's what the whole goal is when you solve. So the first thing we always have to move is this 13. We need to move it over to the other side. So if I wanted just a vertex, we'd be done. If I ask you to solve for the x-intercepts by completing the square, you actually have to keep going. So we add the 13 over. And we get x minus 2 squared equals 13. Then we have to take the square root to get rid of this squared. When we take the square root, you guys, we have to take the positive and negative value. Don't forget that plus or minus sign, or you'll always only get one x-intercept. X minus 2 equals plus or minus root 13. Now, if we can reduce the 13 at all, like if we could break it into a perfect square, like 13, if you could divide it out into a 4 or a 9 or 16, then you would, yeah? No. Yes. You waited that long? You waited that long? Like, I even finished the vertex up here, like, ages ago. Ages. Like, I actually turned a whole year older in this process, and you still didn't comment until I got to this part. Do you notice how I turned that to me, your fault, even though like I totally, yeah. That wasn't actually planned, but it did work on this. Okay, so negative 15 equals 0, as opposed to negative 13, because that makes absolutely no sense. So we move the 15 over, and we're going to get square root 15, not 13. 15 still doesn't break down into anything, right? I can't divide it by 4, and I can't divide it by 9. I can't divide it by a perfect square. So that's as low as it gets. So I have positive or negative 15 with a 5, because that's right, as opposed to 3, which is wrong. X equals, move the 2 over. The 2 goes in front of this plus or minus sign. So it's 2 plus or minus root 15. Now this is actually 2 x-intercepts, you guys, but we just write it like this. But if I asked you to say, for example, on the unit test, I could say to you, or major quiz, I could say, determine the biggest x-intercept to the nearest tenth. Then you'd have to solve these out. So you'd go 2 plus root 15, and it would give you one of them. And then 2 minus root 15 would give you the other one. Okay? And you'd give me the biggest one. Or if you turn it to decimal. Or I could say, determine, solve by completing the square, or solve and give me exact values in the form a plus or minus root b. What's a plus b? They happen a lot in grade 12. Yeah, so you have to get used to them. Okay, now try the next one and don't do as I did, add correctly. Okay, so our first thing, we have to move this 3 over. Then you have to pull the 1 out. And you're left with x squared minus 10x plus blank minus blank square bracket minus 3 equals 0. Blank equals b divided by 2, so negative 10 divided by 2 squared, which is negative 5 squared, which is 25. Okay, and then 1, and what multiplies give me 25 and adds give me negative 10, x minus 5, x minus 5, so x minus 5 squared. 1 times negative 25 doesn't change it. Minus 3 equals 0, and we get x minus 5 squared minus 28, yes, equals 0. Okay, now the 28, you guys, at this point, the vertex is going to be at 5 and negative 28. When we go to solve this, this 28 is going to be able to break down. So we have to watch that, make sure we break it down to the lowest radical. So we're going to add the 28 over. And we get x minus 5 squared equals 28. Square root. When you square root, you take the plus or minus. Now, root 28. I'm just going to go down here and show you it. If I take square root 28 from last year, I could break it up into root 4 and root 7, correct? Technically, you can write them as 2 different radicals if you want. And root 4 is just 2. So you get 2 root 7. Because 28 can break up into root 4 and root 7, right? Because you need to reduce it. A lot of the time you guys were taught factor trees, and then you'd circle the ones that, and then you'd write it. But in reality, root 28 is just 4 times 7, right? Is 28 4 times 7? We agree? Yes. Every radical, if you have more than something multiplied in a radical, you can split it up into 2 radicals like this. Root 4 is just what? 2. Root 7 is just root 7. Done. If you want to do the big factor tree, you can go right ahead. It works as well. But you want to try and break it up into the biggest radicals. So 4 or 9 or 16. You have to break it up into perfect squares though, right? Like 4 or 9 or 16 or 25 or 36. If you can't break into those, then it's as low as it goes. So we have x minus 5 equals plus or minus 4 root 7. And then add the 5 over. So x equals 5 plus or minus 4 root 7. You guys will always be reduced, the radical. Can't even be sneaky. It's thicker. It's 2 because the square root of 4 is 2, which is why I wrote 2. But then I wrote 4 because I'm dumb. It's 2. Let's do this one first. So we have to move it over. 3m squared plus 4m minus 2 equals 0. Now this one isn't nicely like the 1. You still have to take that 3 out, right? So we take the 3 out, but we take it out of the first two terms. So m squared plus 4 divided by 3m plus blank minus 2 equals 0. And for those of you who want to put that as a terminating decimal, it is not. 4 divided by 3 is like 1 point, I don't remember, 3 maybe? Yeah, it's 1.33333333333333333333333333333. If you will 1.3, that is not 4 over 3. Put 1.3 in your calculator, math enter. You will not get 4 over 3. You will get 13 over 10, because that would be moving the, you do not get 4 over 3. Do not write 1.3. It is not 4 over 3. You guys do it on a test. You're like, I just like decimals better. I don't care. It's a fraction. Use it. Like it. Be it. You're in 20-1. In calculus, you do like fraction exponents. So, deal. Like it. Be it. You are it. Okay. So, blank equals b divided by 2 squared. B happens to be 4/3 divided by 2 squared. When you divide by 2, it's like multiplying by a half. So you actually get 4 over 6. Or 2 over 3 squared. And when you square 2 over 3, you square 2, which is 4. You square 3, which is 9. So our blank is actually 4 over 9. Then we write our number again, 3. M. Like I said, if you don't skip steps, it's nice. You move back to here. It's going to be plus 2/3 because you just look back one. Squared. Everyone forgets the squared, right? Then you have to remember to multiply this number by this one. So 3 over 1 times negative 4 over 9 is negative 12 over 9. Negative 12 over 9 reduces to negative 4 over 3. And then minus 2 equals 0. So you get 3m plus 2/3 squared. If you want to add these, or add two negatives, I guess, or subtract them, whatever you want to call it, you have to get a common denominator. So I have to times this one by 3 over 3. So you get negative 6 over 3 is the same as negative 2. So you actually have 3m plus 2/3 squared minus 10 over 3 equals 0. Add your 10 over 3 over. Then this one has a little bit of an extra step. Because of the last ones, we always had just a 1 in front of here, so we didn't actually have a number in front, right? But we do this time. 4 over 3 comes from 3 times negative 4 over 9 is negative 12 over 9. And negative 12 over 9 reduces to negative 4 over 3. Because you can take 3 out of both the top and the bottom. Move your 10/3 over so you get equals 10 over 3. And then we have to move this 3 over first before we square root. So we have to divide it. Now, when you divide by 3, dividing by 3 over 1, it's like multiplying by 1 over 3, right? You have to flip and multiply. So if you're dividing by 3 over 1, it's the same as multiplying by 1 over 3. So you actually get m plus 2 over 3 squared equals 10 over 9. Square root both sides. Now this is also from grade 10. M plus 2/3 equals root 10. You can split this just like when you had the root underneath and you had multiplication, right? We could split it up. Like when I had root 4 and root 7 underneath, you could go root 4 times root 7. Same thing here. If you have root 10 over root 9, or root 10 over 9, you can rewrite that as root 10 over root 9. Now, why would you want to do that? Because root 10 is 10. What's root 9? Root 10 is root 10. Sorry, what's root 9? 3. And so you're going to get m equals, sorry, it was the plus or minus sign. M equals negative 2 over 3 plus or minus root 10 over 3. And the reason why you want to do that is they're both over 3, so you can just put them together. So you're going to get negative 2 plus or minus root 10 all over 3. Most often when you pull a number out front, they'll have like a number like a 6. If you pull a 3 out, they'll have a 6 in the middle, so then it works out to a 2, so it's nicer, but sometimes you'll end up with fraction. Okay? Okay, flip over to the next page. So the following are quadratics where the value of b equals 0, so there's no x term. To solve the following, use the square root principle. This one is way better when you don't have a b. So all you would do if you don't have a b value is you just keep the squared on one side and everything else on the other. So for this one, we're going to subtract 73. And we get negative 30, not negative 30, negative 3d squared equals negative 39. No. What does it equal? 30%. 39. I was right. Okay. Divide by negative 3. And d squared equals 13. And then you just square root. But what do you have to remember when you square root? Plus minus. So d equals plus minus root 13. So when there is no like d value like 3d or 4d or whatever there, you can literally just get all of the constants, the ones without variables, to one side, the squared on the other side, and just solve. It's easier. You don't have to complete the square. Now this one here, an extraneous root is a number obtained in solving an equation which does not satisfy the initial restriction. The catch with any of these is you are taking the square root of a number, correct? Every single time when you're completing the square at some point, you're rooting so that you can get rid of that squared. If you square root a negative number, so say I had it like this, and just pretend this is where we were. So say I had 3x plus 2 squared plus 13 equals 0, let's say. Say I was at that point, okay? I'm going to subtract the 13 over, so I get 3x plus 2 squared equals negative 13. I'm going to divide by 3, following all my rules, and then I have x plus 2 squared equals negative 13 over 3. And then I square root. And when I square root, I take the plus or minus. You cannot square root a negative number. Put in your calculator, it'll error you. Go square root of -4. It errors. You can take negatives of odd roots, so like the cube root of -9 would work. Why does the cube root work and not the square root work? Well, the cube root, if I did the cube root of, let's say 27, it would be 3 times 3 times 3. If I did -27, it would be negative, negative. You end up being able to pull out a -3 out of the whole thing. So when it's odd index, you can have a negative under the root. But when it's a square root or a fourth root or a sixth root or an eighth root, you can't have a negative underneath. The moment you get a negative underneath, you can stop this question and just say there are no roots. How is that even possible? Well, if you put the quadratic into your calculator, this quadratic is going to be above the x-axis. So there aren't any places where it crosses. So how do you know by completing the square if your graph is completely above or completely below? You're going to get a negative under the square root sign because you can't do that. Okay, so if you get a negative, stop freaking out. Put the equation in your calculator and see, is it completely above or below? If it is, that's good. You should have a negative under it. Okay. What I always say too is, you know what your ultimate goal needs to be, because you can always punch your equations in your calculator. I don't take away your calculator, right? You can always punch your equations in your calculator and you can always check them and see what the x-intercepts are. And you can always turn these roots answers into decimals, right? So you can match and see if your calculator is the same. Then people will say, well, I can just use my calculator all the time then. There's no way you can take your calculator decimal and turn it into 2 plus or minus root 3 over 7. It's not going to happen. You can turn that into a decimal and match to your calculator to see if you're right. You can walk away from the test and say, hey, I know I got the question right, or hey, I got the question wrong. But you can't turn the decimal from your calculator into the exact value form. Okay, so that's how I'll know if you did it or not. So flip to this assignment. Do these. And I'm going to hand out that assignment that if you do, you can get that bonus on the major quiz.